What if the most significant discovery in astronomy wasn't just another space rock but something far more extraordinary? Recent observations of 3I-ATLAS have revealed characteristics so unusual that some scientists are questioning everything we thought we knew about interstellar visitors. This cosmic wanderer's behavior is challenging our understanding of what's natural in the universe. Discovery and initial detection. What are the odds of spotting a cosmic needle in the infinite haystack of space? On July 1, 2025, the ATLAS telescope in Rio Hurtado, Chile, achieved exactly that, detecting a faint moving object initially catalogued as A11PL3Z. This discovery marked a historic moment as astronomers realized they had found the third confirmed interstellar object ever detected by humanity. Following the groundbreaking discoveries of 1I Oumuamua in 2017 and 2I Borisov in 2019, this new visitor was officially designated 3I-ATLAS, and given the cometary classification C2025N1. However, what makes this detection particularly intriguing is that despite its eventual brightness, 3I-ATLAS remained hidden from earlier detection due to its challenging viewing angle as it approached from the direction of the Sun. This late discovery, despite the object entering our solar system months earlier, raises questions about how many other interstellar visitors might have passed through undetected. The object's trajectory and timing suggest it may have been deliberately positioned to avoid early detection, a characteristic that has captured the attention of astronomers worldwide. Within days of confirmation, observatories globally began tracking this mysterious visitor, but its behavior would soon challenge conventional explanations for interstellar objects. Extraordinary orbital characteristics. How can an object from interstellar space follow a path so perfectly designed for studying our solar system? 3. I-ATLAS possesses orbital characteristics that defy the laws of probability and challenge our understanding of random cosmic motion. The object follows a hyperbolic orbit with an extreme eccentricity of 6.14, making it the most hyperbolic trajectory ever recorded for any confirmed interstellar object. Racing through space at an incoming velocity of 58 kilometers per second, it holds the record as the fastest interstellar visitor humanity has ever detected. What makes these characteristics truly extraordinary is the object's trajectory alignment. Its path lies almost perfectly within the ecliptic plane, with astronomers calculating only a 0.2% probability of such alignment occurring by random chance. This precise positioning allows 3I-ATLAS optimal viewing angles of all major planets in our solar system, resembling a carefully planned survey route rather than the chaotic trajectory expected from a naturally ejected object. The mathematical precision of this path has prompted some researchers to question whether natural gravitational interactions alone could produce such an unlikely orbital configuration. Unlike typical interstellar objects that enter our solar system from random directions, 3I-ATLAS appears to follow a route specifically designed for comprehensive planetary observation, raising profound questions about the true nature of this enigmatic visitor from the depths of interstellar space. Suspicious planetary encounters. What are the chances that a random visitor from interstellar space would pass by every major planet in our solar system? The trajectory of 3I-ATLAS presents astronomical improbabilities that challenge conventional explanations for natural objects. Calculations reveal that this mysterious visitor will pass unusually close to Venus, Mars, and Jupiter, with astronomers determining only a 0.005% probability that such planetary encounters could occur by random chance. Even more suspicious is the timing of its closest approach to the Sun, which occurs precisely when Earth's position blocks optimal observation opportunities, an event with only a 7% probability of random occurrence. This strategic timing ensures that 3I-ATLAS remains partially hidden during its most vulnerable moment of solar approach, when increased solar heating would reveal the most about its composition and internal structure. The object's path resembles what mission planners would design for a reconnaissance spacecraft conducting a comprehensive survey of our solar system. Each planetary encounter provides optimal positioning for studying gravitational effects, atmospheric compositions, and planetary characteristics that would be valuable to any advanced civilization seeking to understand our cosmic neighborhood. The mathematical precision required to achieve such a trajectory through natural ejection processes appears virtually impossible, leading some researchers to suggest that 3I-ATLAS might represent something far more sophisticated than a simple interstellar comet drifting randomly through the galaxy. Physical properties and anomalies. How can an object be simultaneously ancient beyond imagination yet surprisingly well preserved? 3I-ATLAS presents a fascinating paradox in its physical characteristics that, honestly, challenges our understanding of interstellar object evolution. With an estimated diameter ranging from 1 to 12 kilometers, it's significantly larger than previous interstellar visitors, making it the most substantial confirmed object from beyond our solar system. Age estimates suggest this cosmic wanderer is over 7 billion years old, predating the formation of our entire solar system by billions of years. Despite its ancient origins, 3I-ATLAS has earned the distinction of being the brightest interstellar object ever observed, reaching magnitudes that allow detailed study with ground-based telescopes. The object exhibits a 29-hour rotation period with remarkably minimal brightness variations, suggesting an unusually spherical or elongated shape that maintains a consistent cross-sectional area as it spins. What puzzles astronomers most is how an object of such extreme age could maintain its structural integrity during billions of years of interstellar travel, surviving impacts from cosmic dust, radiation bombardment, and gravitational perturbations from passing stars. The preservation of such an ancient artifact raises questions about its composition and internal structure. Most naturally formed objects of this age should show significant weathering and fragmentation, yet 3I-ATLAS appears remarkably intact, leading some researchers to speculate about unusual material properties or construction methods that could explain its extraordinary longevity. Comet-like features versus anomalous behavior. Why does 3I-ATLAS simultaneously behave like a typical comet while displaying characteristics that contradict cometary physics? This interstellar visitor presents a confusing mixture of expected and anomalous behaviors that have astronomers scratching their heads. On one hand, the object displays clear cometary features, including a faint coma and a short 3-arc-second tail, indicating active outgassing as solar radiation heats its surface. Spectroscopic observations confirm the presence of water vapor and dust particles being ejected from the nucleus, creating the familiar fuzzy appearance associated with comets approaching the Sun. However, several characteristics deviate significantly from typical cometary behavior and challenge conventional understanding. Unlike normal comets that develop extensive flowing tails as they approach the Sun, 3I-ATLAS maintains a remarkably compact and dense appearance despite its proximity to our star. The expected dramatic tail development that should occur during solar approach appears mysteriously absent or significantly suppressed. Additionally, the object's outgassing patterns don't follow the predictable models used for solar system comets, with activity beginning much earlier and following unusual intensity patterns. The combination of recognizable cometary features with anomalous behavior patterns creates a scientific puzzle that defies easy categorization. Some researchers suggest these contradictions could indicate an artificial origin designed to mimic natural cometary activity, while maintaining structural advantages that prevent the typical fragmentation seen in natural comets during close solar encounters. Scientific debate: natural versus artificial. Could humanity be witnessing the first confirmed artificial object from another civilization? This question has sparked intense debate within the astronomical community, with Professor Avi Loeb from Harvard University leading controversial discussions about 3I-ATLAS's potential artificial origins. Loeb points to the statistically improbable trajectory, precise planetary encounter timing, and anomalous physical characteristics as evidence that this object might represent advanced technology rather than natural formation. His arguments center on the mathematical impossibility of achieving such a perfectly designed reconnaissance trajectory through random gravitational ejection from a distant star system. The object's strategic positioning for optimal planetary observation while minimizing detection opportunities suggests intentional design rather than cosmic coincidence. However, the majority of the scientific community strongly opposes these interpretations, dismissing such claims as irresponsible speculation that, honestly, undermines serious astronomical research. Leading planetary scientists argue that unusual characteristics can be explained through natural processes we don't yet fully understand, pointing to the complex dynamics of planetary system formation and ejection mechanisms. They emphasize that extraordinary claims require extraordinary evidence and current observations, while puzzling, don't provide sufficient proof of artificial construction. The debate highlights fundamental questions about how we interpret anomalous data and the criteria required to consider non-natural explanations. This scientific controversy demonstrates the challenges of studying truly unprecedented phenomena that push the boundaries of our current understanding. Spectral analysis mysteries. So, what happens when the chemical fingerprints of an object contradict everything we know about cosmic ice? Well, spectroscopic analysis of 3I-ATLAS has revealed some pretty puzzling discrepancies that honestly challenge our understanding of interstellar object composition. While initial observations detected the expected water ice spectrum, a more detailed analysis actually reveals significant anomalies in the spectral patterns. The observed signals rise precisely where theoretical water models predict they should drop. And this creates a scientific puzzle that's got researchers questioning their fundamental assumptions about cometary composition. This unusual spectral behavior suggests either unknown ice structures formed under extreme interstellar conditions, or maybe even the presence of exotic materials not found in typical solar system objects. The object's distinctive reddish coloration adds yet another layer of mystery, resembling asteroids from the outer asteroid belt, rather than the neutral or blue colors we usually see in pristine comets. Standard models just can't adequately explain this color combination along with the observed outgassing patterns, which suggests some pretty complex surface chemistry, likely altered by billions of years of cosmic radiation exposure. And to complicate matters even further, the active coma surrounding the nucleus interferes with spectroscopic measurements, making it tough to distinguish between emissions from the solid surface and gases in the surrounding cloud. Advanced computer modeling, which tries to separate these contributions, has so far yielded inconsistent results, with some analyses even suggesting the presence of materials that really shouldn't exist in natural cometary bodies. These spectral mysteries have prompted some researchers to consider whether 3I-ATLAS might contain artificial materials or, maybe even represent a type of object completely unknown to current astronomical science. Dark forest hypothesis implications. Could 3I-ATLAS represent evidence of a cautious alien civilization following the theoretical dark forest hypothesis? This controversial idea suggests that advanced civilizations, remain hidden to avoid detection by potentially hostile neighbors, conducting reconnaissance missions while minimizing their own exposure. The behavior of 3I-ATLAS, honestly, eerily matches this theoretical framework, displaying what appears to be deliberate stealth-like characteristics designed to avoid detection during its most vulnerable moments. The object's trajectory ensures it remains partially hidden behind the sun during its closest approach, when increased solar heating would reveal the most information about its internal structure and composition. This strategic positioning allows comprehensive study of our solar system while minimizing opportunities for detailed observation by Earth-based telescopes. The timing and trajectory appear designed for maximum information gathering with minimum exposure risk, resembling the cautious exploration strategy that an advanced civilization might employ when investigating a potentially inhabited star system. The dark forest hypothesis, popularized by Chinese science fiction author Liu Cixin, suggests that civilizations remain silent because revealing their location invites destruction by more powerful neighbors. If 3I-ATLAS represents such a reconnaissance mission, its behavior demonstrates remarkable sophistication in balancing scientific objectives with survival instincts. The possibility that we're witnessing humanity's first encounter with alien technology conducting a stealth survey of our solar system raises profound questions about cosmic civilization protocols and our place in a potentially crowded but silent galaxy filled with hidden watchers. Historical context and lessons. The discovery of 3I-ATLAS carries profound implications shaped by our previous experiences with interstellar objects and, the scientific opportunities we failed to fully capitalize on. The first interstellar visitor, 1I Oumuamua, caught astronomers completely off guard when Robert Warwick detected it using the Pan-STARRS 1 telescope in 2017. The object's unexpected rapid exit from our solar system left the scientific community with more mysteries than answers, particularly regarding its strange acceleration behavior that just defied conventional explanations. This missed opportunity, honestly, highlighted critical gaps in our rapid response capabilities for studying rare cosmic phenomena. The second interstellar object, 2I Borisov, discovered by amateur astronomer Gennady Borisov at his Crimean Observatory in 2019, provided a redemption opportunity that was better utilized but still constrained by available technology and coordination limitations. Mark Norris from the University of Central Lancashire emphasizes that 3I-ATLAS represents our most comprehensive opportunity to date for properly investigating an interstellar visitor using advanced instrumentation and coordinated global observation strategies. The improved detection capabilities of contemporary sky survey systems, combined with enhanced international communication protocols, have enabled unprecedented real-time coordination among research facilities worldwide. Michelle Bannister notes that these lessons learned from earlier interstellar encounters have truly revolutionized our approach to studying these remarkable cosmic messengers. Future observations and implications. What will the next few months reveal about the true nature of this enigmatic visitor? 3I-ATLAS will reach perihelion on October 30, 2025, providing the most critical observation window in its entire passage through our solar system. Following this closest solar approach, the object will re-emerge from behind the Sun in December 2025, offering a final opportunity for comprehensive analysis before it begins its permanent departure from our cosmic neighborhood. Multiple telescopes worldwide are coordinating the most ambitious interstellar object observation campaign in astronomical history, including space-based platforms like the James Webb Space Telescope and Hubble Space Telescope. These coordinated observations aim to resolve fundamental questions about the object's composition, internal structure, and true nature before it becomes too distant for detailed study. The data collected during this critical period could revolutionize our understanding of interstellar objects and their implications for planetary defense strategies. If 3I-ATLAS proves to be artificial, the discovery would represent the most significant moment in human history, confirming that we are not alone in the universe and that other civilizations are actively studying our solar system. Alternatively, if proven natural, the object would still provide unprecedented insights into planetary formation processes in distant star systems and the evolution of materials during billions of years of interstellar travel. Either outcome promises to transform astronomy and our fundamental understanding of our place in the cosmos, making the coming months among the most important in the history of space science. As 3I-ATLAS approaches its moment of truth during perihelion, it carries with it the potential to answer humanity's most profound question: are we alone? Whether this mysterious visitor proves to be an ancient comet or something far more extraordinary, it represents a pivotal moment in our understanding of the cosmos. For more groundbreaking space discoveries that challenge everything we thought we knew, subscribe to Space Facts, where the universe reveals its most stunning mysteries.